Hello, Nalini. So, Laurent, did you have a chance to attend the RAW meeting? I did not see you in the room, but just in case, because there was Bob there saying interesting things about Shake.
Yes, we were there.
And there is Bob, actually. So, do we have a note taker already? Is there somebody in the room who's willing to help? Like a very famous Dominique? Because I see somebody's touching, it's moving by itself. This is Sergio. Okay.
You can start if you want. Everything is fine, Pascal? Or?
Yes, I'm connecting to Tulip right now. Okay. So I'm in the Zulip. Just testing that it works as well, and we will start. Oh, we can start. Okay. So let me do the introduction.
Okay. Go ahead.
And so there we go. So welcome in the room. This is the IETF meeting, Lp1 workgroup meeting. If that's not what you came in for, then you're in the wrong room. We have just 1 hour on the Pact Agenda, so I'll start without waiting more and move forward. Next slide, please.
We have Ivan and Dominic.
So Laurent, are you moving the slides or do you want to give me the...
Up to you.
Well, please move it. Just next slide. So as usual, we have the traditional IETF not well. So be aware that we have a code of conduct that's BCP 15.4 and anti-harassment rules. If you feel that you're a victim of anything related to harassment or bad conduct, please contact the Ombuds team, and you can see the link on this page. And you will see the exact same slide on every other meeting. And obviously, as usual, we've got rules about IPR. So if you're aware of IPR, a new IPR, undisclosed IPR that is being discussed today, please mention it to at the mic or to the chairs or on the mailing list, or refrain from talking about that IPR at all. Next slide. So we have 2 types of participants since COVID, as you know. Some will be in person in the room, some will be remote. If you're in the room, please join the Mythicolite application that you can download from Data Tracker on your phone, so you can join the MIC queue. The chairs will be handling the MIC queue as a single queue for remote and local participants. For remote participants, please keep your audio and video off unless the chairs are giving you the right to speak. And yes, if you can use a net set to avoid echo. Next slide, please. And so these are the resources that you already have seen a number of times for this particular meeting. Next slide. Okay, so as I said, we have a packed agenda. So we'll be going through the agenda bashing, and it's going to be me, I guess. Then Anna will give us the status of the shakeover and BIoT. Laurent, the Shake data model, and both of them are, at the later stage for this working group. So we've been asking the document publication. Then there will be the compound hack and 2 slots, one for compound hack and one for Shake over Sigfox with Sergio. Then we'll have an interesting new proposal by Bob Moskovich about having a Shake IP number. Note that this work is not currently chartered, but we would like to test interest in this room. Then I'll be talking about the architecture draft that has evolved, and we'll be discussing about opportunities to recharter based on the recent evolution of what people want to do with Shake. Next slide, please. So, is there anything people want to change, add, modify in this agenda before we move on? Silence is consent. Okay. So work group status, we basically had a number of milestones which are passed for the Shake over Sigfox and Shake over NB-IoT. We are not that bad for the Shake over NB-IoT, and the Shake over Sigfox was kind of delayed because of the need to generate the compound hack separately. But we are getting there for all our documents, so we are not that bad. Actually, being only a year off is not that bad. Now we still have we still have an item for the OAM, and well, we pushed it to the end of the year, but we'll see if there is still interest in this group to produce it. Next slide. So document advancement, as I already said, we have great progress for the NB-IoT and Young Data Model, for which the publication request button was pushed, and the early IETF last call reviews started piling for the Young Data Model. So I hope Laurent gives us a status on that, in particular the Young reviews. I don't think anything has yet started for the NB-IoT. I mean, the queues are actually loaded for many of our ADs. So as you can see, there are new versions for all of the documents, either in June or in July. So we are working and progressing very well in this group. So thank you all for this. Next slide. And yes, as I said, at the end of the meeting, we'll be discussing rechartering. And basically, the main reason for that is, on the one hand, we want to extend Shake to new technologies, and Bob is discussing some basically flying object networks. We have PPP over Ethernet, so we can do PPP, so we can do PPP over anything, including Ethernet and Wi-Fi. We've got the work that Carlos has started for 15.4. 15.4 was initially chartered, but mostly as a wide area, low power wide area network, like 15.4 in G, basically in this type of networks using sub-gig. But now we are looking at 15.4, 2.4 gig, for WPAN, or even wireless body area network, 15.6, etc. So basically doing what 6low has done with 6LoWPAN, generalizing to other technologies, see what we can do, and then look at other things we could be doing with Shake. So Shake at the moment does compression. It also does fragmentation. It has reliable fragmentation, but as Bob hinted, it doesn't have FEC, for instance, to do reliability, but not with ARQ, really forward reliability, which would save the return channel. So looking at things like that could be of interest. And then there is Bob's proposal for the Shake next header, which is also not in the charter. So basically looking at how we expand Shake for other spaces, larger spaces, could be of interest for this group, and they would like to take the sense of the room and then sense of the working group, if people are interested in pursuing the work in those directions. And with this, we'll move with the first agenda item, and I think that's Anna.
Yeah. Hello, do you hear me?
Yes, we hear you.
Thank you very much. So I will present the last version of the CHIC over NB-IoT draft we published on July. Next slide, please.
You can. I give you the control. So you can.
Okay, sorry. Okay. So we have made in this version 10 the inputs from the review of Pascal. Thank you, Pascal. Principally, the references were arranged in formative and normative. We also updated the cross-reference with the sections. Most of needs about the reference, because it was very difficult to define it with the new XML version 3, the 3GPP references. It was a little bit complicated. So one thing that we can say of this draft is that more of the features are recommendations for 3GPP in order to use CHIC for the NB-IoT network. So one of the comment of Pascal was if we need to define an MTU size of 1,358 bytes. So the thing is that we are recommended to use this MTU even if the 3GPP networks accept larger sizes of 1,600. So it's enough for a normal IP packet. But in this case, you will have a segmentation in layer 2. So to avoid that, we recommend to use a smaller MTU for NB-IoT in order to avoid using the RLC segmentation. But that doesn't limit the use of bigger MTU in the network. So the other comment was about the different stack we have in the draft. So again, we have divided the draft in 3 use cases. The first one is the use of CHIC in the radio link, where we have the IP, PDCP, RLC, MAC stack. CHIC is included in the PDCP layer. And in this stack, you have a segmentation in RLC. So most of the fragmentation, we decide not to use it. We only use the compression of CHIC, except for the transparent mode, where there is no segmentation in RLC. And then we decide to recommend the use of CHIC fragmentation. The other use is in the node access stratum in DONAS, where you have the IP packet over the RLC MAC. So there, CHIC will be used in the RLC layer. And again, you have the segmentation in RLC. So we are using only compression, but not fragmentation. And in the last case, you have an end-to-end connection. You have IP over CHIC over MAC. And that's in that case we recommend to use CHIC compression and fragmentation. So that was the two more related technical points of the review, the last review. So if you have questions, this draft has been sent to the ISG for publication.
Rick?
Many thanks, Anna. Do we have any question in the room?
I have no time to jump into the queue, sorry. Just to tell you that next step is an AD review by myself, but I'm busy this week, as you can guess, right? So don't expect anything moving before mid-August, most probably.
Okay.
Thank you, Eric.
Thank you.
Okay, Pascal, can you take control during my presentation?
Okay, I will do that. if I can. Okay, so I took the control away from you. Now I need to share slide.
Okay, so do you hear me?
Yes, go ahead.
Okay. So this is the 14th version of the young data model. So I think we are converging right now, and we have something that is quite nice. So next slide, please. So I just remember what covers this young data model. So the version currently is 11 of July, and it covers only what is defined in published RFCs. It's 8724 and 8824. So it covers compression, fragmentation, and no compression for IPv6, UDP, and CoAP and score. So it defines the rules and also the parameters that we use in for these actions. So what we have done, and what is one of the main changes since the previous version, is that timer values, and I will explain in the next slide. So next slide, please. So we are here, all the modification we have done in the model until this version 14. So the first one was to clarify the old one, because it could have an ambiguity, because you have an L and the 1 that are very similar. And of course, we cannot change the standard. So we put a dash between all and 1. And we also change for the value, for the target value and parameters, we change the name position, that could be ambiguous with the field position we have in other places, and we call it an index now. And the main change is in the way we manage timer. Before it was uint64, and we change it in something that is more flexible. And if you can go to the next slide, we use a tick duration and a tick number. So the tick duration is a formula where you have 2 power of tick duration divided by 10 power 6, that give us, when the tick duration is 0, a unit of 1 microsecond. And if you increase the tick duration, you increase this unit. And for example, when you put the value 20, then you have about 1 second for each tick duration. So then, to set up a timer, we just give the number of ticks we want, or tick number. And this way we can cover different range and different usage for SHIC. One can be up to the microsecond, so it could be useful for real time. And we can go, if we increase the tick duration, to several years, a lot of years even, for the timer. So what we choose to use as a default value is 20, because we have a tick of about 1 second, and the maximum timer is 19 hours, and the LoRaWAN recommendation is about 12 hours. So we have something that fits well the needs for Lp1. So next slide, please. So we got also a review, the young doctor's review of the model. So thank you for Martin Thompson and John Clark. We got a very, very nice review that makes improving the document. So I will not go into all the details. I have done that on the mailing list. But they raise a major issue on the nature of the rule. So right now in the model, we adjust the choice for fragmentation, compression, and no compression. And this choice is not exclusive. It means that the device can, in the young model, you can select both compression and fragmentation. So that's not what we need, because in a SHIC, a rule can be either fragmentation or compression, but not at the same time both. So that's why I propose a change. So we have to discuss on that on the mailing list. So next slide, please, is to add a new leaf that is rule nature, and this rule nature will tell if it's a compression or a fragmentation rule. And inside each definition of the compression content and the fragmentation content, we make a test to see if we are on the right nature. And we don't need any more no compression as a choice because it was ineffective and it will not have been reached at any time. So that's a significant modification we made to the model, and it will be published with the new version of the draft. So next slide. So just to conclude, and it's something that came when we had to write the security review or security chapter, is that right now the young data model we are using is just respecting what is said in the RFC, and it's a way to have something common between a device, a core chic, or app chic, and maybe a repository when we will have the rules. But until now, we don't identify the device, and it's something that is very important, and we need to have this in the architecture draft. So next slide, please, to identify the device. So we have, I think, to work on that part. So how we do the authentication. For example, in OpenShift, we have two kinds of devices. We have the ones that are directly connected to internet just for test, where we have an IP address in the device. And we have the LoRa one, where we have the dev UI at the end. So this is one way to represent it in OpenShift. We have also other documents, like the RFC 1999-39, that define a URL for this device. So we have to see if it's convenient with compact representation, because this is URN and they are in ASCII. So there is other work at the IETF to compress URL and URN. So maybe we can use it, or maybe also use directly a compact identification in the young model. So that's one thing that will be important to define. And the last point is that when we will have these IDs, then we can add this ID to the young data model we have defined. And for example, if we don't put IDs, it could fit a point-to-point model. If we just put the device ID, as we are right now in the start topology. And if we put the device on the core, then we can reach the constraint from mesh network. So that's some evolution we will have to discuss. And we need also some words for the security section about these things, because of course, if we don't have identification, that anybody can modify a young data model, and it's something that could be unsecure. So I think it's my last slide. If you have questions.
Thank you very much, Laurent. And we'll be moving to Sergio. So Sergio, can you jump to the mic?
Yes, hello, can you hear me?
Yes, this is great. So please go ahead.
Hello, I will present a compound act draft, in this case, the path to publication. Can you put the next slide, please?
I give you the control.
How do I? There you go. Well, one of the biggest changes that we did on version 5 was that we changed the way padding bits are handled. Before, we said that padding bits must be 0. According to the review with Dominique and the spirit of the RFC 8724, that it has no padding bits defined. The idea was to not specifically define the padding bits, but we needed a way to actually differentiate the last window from extra bits. So we decided that we will use m bits as 0, that can be used when you need to add more than m padding bits to the message. This way, this m bits signal the end of the compound act. Other changes were more specifically format. We remove any reference to the receiver abort. We also remove any bound of the check compound act to ACON error. This was removed in introduction and in many other areas. And also we provided compressed bitmap examples on how to use the compound ACK with compressed bitmap. Another big change that we did actually was that we added the complete section of the RFC 8724, section 843, the ACK on error mode, with all the changes on how to use the compound ACK. Actually, it was difficult to read where the specific changes had to be done. So in this case, we added a new text, all text, to the complete section. And this way, we believe it's more clear to read and actually know where are the differences between the compound ACK and the RFC 8724. Also, we define the compound ACK as backward compatible. In this sense, we specify that the RFC, that the ACK on the RFC 8724 is a special case of the compound ACK, in the case with one window of tiles. And finally, well, we need to define the next steps on this draft, and we would like to thank also Dominique for the review and all the work that he has done. Thank you very much.
Any question in the room? Nobody jumps? So yeah, let's move on. If you don't mind putting the other slides. Let's move on to the SHIC over Sigfox.
Okay. You hand me control. There you go. Okay, well, this is the status of the SHIC over Sigfox draft. In this case, we would like to thank Anna for the Schaeffer review, and these are the main changes in version 11. We did some changes in the introduction in abstract. We did some changes regarding the acronyms. We also changed some terms about the predictability of data flows to traffic flows to be more according to RFC 8724. We added some legends in figure 1 to actually understand what its symbol stands for. Also, we stated that we conform with Appendix F. We added some new text that is actually, well, in this case, that we recommend a message to be sent each 24 hours to enable the downlink transmission. Also, well, we changed some terminology of how it was written in the draft. Also, well, we added some information about the apps and downlink messages, how the downlink is enabled in Sigfox. And well, this is a topic that maybe we can discuss at the end regarding the D tag and the rule ID. We added the information regarding that we believe that with this amount of rules IDs is enough for the purpose of identifying different flows in the transmission. Also, we added some recommended values for inactivity timer and retransmission timers. And fine, yes. And another question was regarding the RCS. In this case, this was also presented in last IETF. We changed how the RFC is calculated. Actually, what we send is just a number of tiles of the last window. And that way we are able to know how many fragments are lost in the last window, and we are able to reconstruct the message, as the CRC is already checking layer 2 of the Sigfox fragment. So I think this is the final one. Thank you very much. If anyone has any questions.
This was great, Sergio. Thank you very much. Very informative, and you maintained within the short window that you had. So
just one last comment. I have a new version of both drafts to be uploaded with the needs both. I correct the needs in both, and I fixed the last email of Anna from the mailing list. Thanks to Anna again. So we did that last changes. So the drafts are all really ready, I would say, at this point.
Yes, so the shepherd, as people guessed, the shepherd for the first document is Alex actually, and the second is Anna. So that's why you got the reviews for Anna, and I guess you will get the review from Alex, the Shepard review from Alex very soon. I didn't mention it, but Alexander could not be with us today, so it's very sad. But yes, we will do without him. Anna, yes, please move. Anna?
Yes, I have a question about do we need to wait until the Compound Act has been published to publish 6FOX, or we are going to send it both at the same time?
Oh,
Because
well,
6FOX is used in the Compound Act.
you can press the button. Oh, maybe Eric wants to speak, but you can press the button. Eric will know that he expects both documents. And anyway, the IETF will publish them at the same time because of the dependency. So even if the shake over 6FOX progresses faster, since that's this normative dependency, it will have to wait in misref at the RFC editor queue. But it won't be long because the two of them will be posted, almost simultaneously.
Okay. So just to be clear, I will be publishing new versions of the draft today or tomorrow to be considered in any further review.
Okay, well, expect the Shepard review by Alexander very soon. And once Anna is ready and you have answered all the questions, about IPR, etc., we'll press the button requesting for publication. So Eric knows that something is coming.
Thank you very much, Pascal.
We need to move to Bob. Otherwise, we would start being late, which would be very bad after the excellent timing you made, Sergio. So Bob, yes. And Bob is in the room, I guess. And Bob, I will ask you to speak near the mic and stay very.
Yeah, I'm right by the mic. I'll take the mic out and hold the mic and go. Okay, this presentation is of as IP protocol number for SHIC. And this did not come out of my work on forward error correction, which I did in raw. So please go to the next slide. I'll say why I'm doing this. And networks are complex, and what if constraint links is within the path? There's endpoints know the constraint, but have no control over it. This is an avionics on an Ethernet on the plane, and knows it's got a control link going to a data center somewhere on the internet, and knows that link is there, but cannot interact with it directly. All IP content is with a non-compressed security wrapper. There's that as well. An example of this, Diet ESP wants to compress a security wrapper, but how to flag this other than through a special SPI, which is how the draft is right now. DTLS, much of the UDP can be derived from DTLS. Why do I have to carry UDP when I can compress that down as well? So these are two examples of how, if I had SHIC as my header, I can do things. So if IPv6 next header were SHIC, the rules can't compress the transport and all up to the security envelope. Can even indicate what rules fall within the security envelope. Can also end to end. So I gained some additional controls in an end-to-end environment if I were to have SHIC saying that this payload is SHIC, apply the rules. Continue. Effectively, when you do this, SHIC becomes the transport layer. To transport the original transport layer compressed, why have UDP CRC when I have the ICV in DTLS or ESP? Why do I have to also carry the CRC as well? Squeeze it out and then rebuild it. Provide new and valuable transfer functions like an end-to-end forward error correction, which I presented earlier presentation. So this is the how. Here's my technical slide. I have to have one technical slide. Review of the current protocol numbers. I went through them. There's nothing that I can camp on to do this. No, is there any protocol number I can use? No, I can't. I need one. So we have the SHIC protocol payload. A rule ID could be 0 bytes. So basically, you have your role ID. You have the sheik is your protocol ID. You have the role ID, the compression residue, and then whatever payload you have. And standard stuff. You people have been created this, you know it. Okay. But can we really introduce a new IPv6 next header value? Will it just work, or do we need router upgrades? What would happen? Will the routers be dropping? Oh, I don't know this IP protocol number. Drop it. That's a six-man question. What might IP fragmentation result in? Do we need to force don't fragment? Because what is being done, you no longer have a transport length, and now you have that. So these are questions that need to be answered. What else could go wrong? Camp an existing, not use value, really bad idea. Eric.
Quickly, Bob, clarification questions. Eric Vink, the idea for this one. IP fragmentation, there is no don't fragment bit in IPv6. There's the source doing it. So by default, all IPv6 packets have do not fragment.
Oh, okay,
just a detail.
Good. I've not been paying close enough attention. Thank you for that clarification, Eric. Go on. Is this a field of dreams? Isn't that what the internet is about, though? Let's just do it. Adopt it as a work group item. Get this additional functionality for those of us who want to use it end to end. Take advantage of all the good work you have done. One of the other things I realized, again, looking at Diet ESP, and I'm doing a tunnel inside. So once I have sheik as IP protocol number, I have sheik, and the sheik rule says this is Diet ESP, here's our processing header, and in the ESP, the next header is sheik, again, for how to press that ESP payload inside of there. So actually I end up then using sheik twice in that case. And it just flows in the stack, and we don't have, and we limit how much special stuff we have to do. So it's a win, in my opinion. And I ask that this be adopted by the work with this idea. And I don't think we need much in the way of a document to accomplish it. Any questions?
Effectively, there are two people in the queue. I happen to be first, so if you don't mind, can you go back a few slides when you talk about the transport and the discussion about fragmentation, not fragmentation, but FAC, basically. So you mentioned that you presented that at the RAW working group, and effectively that's something which relates to the potential need for rechartering, which will come later. My question to you is, as you know, we have a reactive ARQ type of reliability for the fragment in SHIC.
Right.
What we don't have is a FAC variation for the fragment reliability. And as you know, the LP1 networks are usually very asymmetrical, like the device can send, but the gateway don't have much bandwidth back. So having to send the AX is a pain, and it could be envisioned that effectively FAC for SHIC fragments could be a new possibility for SHIC, right? An alternate fragmentation technique, which seems to fit exactly what the kind of thing that you've been discussing. So please consider that and come back to us, if you want some work to start here, knowing that the transport guys will have to tell you how you do the coding or something. It cannot come from us, but maybe the fact that we are using the coding they recommend could be a work here if we were shouted for it. Sorry for the long.
I guess I'm a little bit too old, and I dealt too much with IPv4 IP level fragmentation. So it's about, oh my God, I'm doing this, and here comes IPv6, breaks my packet up, and then things don't working, and Eric just corrected me, no, IPv6 does not fragment, and we're okay there. So my concern was not what we do inside a sheet with fragmentation, but what happened below us, and it's clarified, I don't have to worry about that. So yes, if we need the fragmentation for whatever, and we have that knowledge, we can use the sheet fragmentation appropriately.
Yeah, because we fragment, so we can take your packet, cut it into, call that 2 fragment, and then say 2 tiles, and send the 3rd tile as being the FAC. And it's all within our global design. And then if you have raw something that can be distributed over multiple paths, and you don't even have to know about that.
Yeah.
So there's a way to build something really nice.
Very good. Okay. Thank you, Pascal. Eric.
So, Eric Vink, the NTD. Carsten has posed a couple of comments into the chat, so Bob, I really advise you to read them. That's about other compression techniques that could be used. Now, regarding this, I agree with the idea, right? Don't take me wrong. I think it would be better to post this draft in area, because for this here, you need rechartering. You're asking for an IP protocol number. I need to reread the charter of area, but I think it fits much better.
And it's like, what's the hope for this and so forth. And they say the effects should be in transport, but I just quickly during lunch, I reviewed the effect framework, and that's all really in streaming applications and not what I want to do. So it's interesting work that can be applied, but what I'm trying to do has really nothing to do with what they did. So it can leverage off what they did. So it's looking, no, where does this properly belong? I strongly believe it's worth doing, and I do need it. So let's get it moving in and get it going. That's what I'd like to see. So in area, Eric, still working with you.
Yes, at least we can express support, and I would be the first one to express support because I really like the opportunities that you're creating doing this. But yes, we'll see what Interia says. And then again, you might think that instead of producing the IP thing in here, you could produce an alternate fragmentation, which is effectively within Charter for us.
Yeah.
But we could maybe extend, I don't know, maybe need to change a little bit the Charter for different things. But is there any other question? Any kind of feeling about the idea, whether it's a good idea or bad idea in the room?
Got head nods going on. And I'll just say one other thing that
you know what? I will use the ANS tool.
No, really clean up die and ESP as well. Make the die and ESP much easier. So we're going to do a hand raise, or
I think he's starting a poll. No?
So I've started a session asking whether you think it's a good idea. Please go to your application, the lightweight in the room, and the normal. You should see the poll starting, and I give you a little bit more time.
Add me to the count since I can't do it.
Okay, so in a very quick time, we got 10 positive, 0 negative. So at least you can go to the Interia saying that the LP1 working group in the room was very positive with the idea that you're proposing.
You need to close.
Anybody else want to comment? I've seen a couple people pop in the queue and then pop out.
Okay.
Okay, I guess that's it. Thank you for your time and thank you for your backing, and I will be working on this because I do need it.
Neat. Thanks so much, Bob. And think about the other part, how it could be accommodated within the SHIC fragmentation framework. So that I mean, I'm sure people in this room would be glad to chat with you on this. Oh, Laurent, you already loaded them because I could have done that. So now you need to hand me the.
Sorry?
Please hand me the ball. Okay. Well, just let me load them. This could be faster. So SHIC architecture. Okay, so it was a long time. Eric was pushing us to update the SHIC architecture, and we basically were like, hey, SHIC architecture kind of documents the steps that the working group is taking and the agreements that we are reaching, the mailing list. And since there was nothing much new to be discussed, the architecture was not progressing. But then, thanks to Carlos for a large part, we realized number of gaps that needed to be discussed, in particular as you extend Lp1 SHIC to other areas than the traditional low power device to gateway type. Then a number of things which were kind of implicit or obvious in Sigfox or LoRa became unknown when you are doing peer-to-peer. We need the role of a device, we need the role of a application, and we need a direction, uplink, downlink, and from uplink from the device to the app, basically, because the compression depends on those information. And guess what? When you're doing peer-to-peer or forwarding on a more symmetrical network, then the implicit who's the app, who's the device goes away, and we have to define that. And the other thing, and that's one thing that Bob has to think about, was my comment in his initial discussion for the IP next header. That was the fact that SHIC lives on a point-to-point connection of some form, a session, I mean, call it the way you want, but for LoRa and Sigfox, there's just one communication between the app and the gateway. So there are not two, so implicitly the SHIC instance is known. But if you talk over IP, I mean, this device could have multiple sessions with that other device. And so finding which SHIC instance, this packet is for becomes harder. And we need to signal it some way. Now we realize that most use cases that we have, the SHIC instance lives on a connection or a session of some sort. You could establish a TCP session, you could establish a UDP, a PPP session, like in the PPP draft. But there is something underneath. There is a peer-to-peer security tunnel. There is something. And so basically, if the rule is when you open a communication pipe between two devices, and well, there can be only one SHIC instance over that particular pipe. And so you don't have to modify SHIC to signal the instance. It's basically because it's derived from the pipe that supports that particular communication. So with this, we can leave SHIC as it is and basically derive the instance from the lower layer, from the communication pipe that contains this instance. Once we have this instance, we can say, hey, well, if it's unclear who should be app, who should be device, then the device is the one that started the connection. For instance, if it's over TCP, then the device that sent the TCP SYN would be the device, and the SYNAC comes from the server. So uplink is along the path of the TCP SYN, basically. Just to give you an example, we don't have SHIC over TCP as far as I know, but it could happen. So with this, we've sorted out, the unknown that Carles has raised in his 802.15.4 work, and actually he is updating his documents to reflect this. So all these were architecture considerations, and we have produced new text to document this. There are cases like Bluetooth Low Energy where there is a hub and spokes. And so for those ones, we do just like we do with gateway and devices. I mean, the hub is quote unquote the gateway, and the spoke is the device side. So for those ones, it's kind of easy. But for really peer-to-peer, like over IP something, we have to have a session of some sort, or connection of some sort, so we can identify the instance. Now, what's next? Well, there are a number of things that have been tried outside, could have been done here. An example of that is SHIC over foo. We have, for instance, a draft for SHIC over PPP we proposed to the int area. And I don't want to send bad waves, in both directions, but we held that draft for a number of IETFs with no review, no comments, no interest from int area. And so the only way to progress that document is probably to bring it back to SHIC, but we are not chartered for to Lp1, but we are not chartered for SHIC over foo when foo is not one of the technologies. So extending to new technologies could be one thing that we could consider as we recharter. And that would enable us to effectively discuss Carles' case with 15.4. That would enable to discuss PPP and any other type of link. Now, there was the SHIC, the next header for SHIC that Bob has been talking about. So I understand that Eric suggests to move it to int area. At the same time, today Bob proposed that row an idea to do network coding between fragments. I mean, that idea is not new, right? But doing it inside SHIC would be quite nice, because even for traditional LP1s, I mean, you would save the retries that we have for the fragments, because we have some form of IRQ in the reliable fragments, that we could make fragments not fully reliable, but a lot more reliable by doing FEC the way Bob presented it. I'm not sure this requires a rechartering. That's something we can check. But basically, this kind of ideas are also something that could impact our charter. So what I wanted to do today is not really propose you charter text or what, but basically figure if the usual suspect in the room are willing to look at more things which we could do in these groups, which are not the current charter, and discuss that over the mailing list. And just to sense interest, I will send a poll to the to the group. So are you interested in taking new work / rechartering? And I'm starting the session. One yes, one no. Oh, that doesn't help. 2 yes, please ping, please say something. New work being possibly check over foo, right? Check over non-classical LP1 technologies. So I'm okay now. So the yes is growing. Okay, I'll give you a few more seconds. So please go to the poll. Okay, and with this, I will end the session. Last chance, ending the session. So for this one, we got 11 to 2. So yes, I think that there are people in the room willing to take more work. And now I'm seeing questions, Laurent and then Carles.
Yes, I think it's a good idea to reshutter, but can we also, I don't know the difficulty, but to change the working group name, because if we say we are in LP1 and we don't do LP1, it's quite strange. So
well, 6LoWPAN named to 6Low. So, I mean, Eric, was that a very difficult thing to do?
Well, it was chartering a new working group.
Yeah, what's in a name, right? So Eric's brain speaking. What's in a name? I would assume changing the name is kind of a useless fight. Change the charter, right, simply.
Okay.
We can have fun in getting the name and, chic over foo, or just call it chic. Work group's name is chic.
Yeah, but if it takes, for me, a new working group to call it shake, then I agree, it's wasted time. So, Carles?
Yes, so regarding the Lp1 architecture draft, first, thanks for the updates, including these extended scenarios beyond the original Lp1 architecture. I hope that perhaps in future updates, the mesh topology might also be explicitly mentioned. And then on the point of chic over foo, perhaps we might also consider chic parts over foo. For example, at the moment in the 15.4 draft that we have at 6Low, what we are using is only the header compression part of chic, and we are sticking to fragmentation based on 6LoWPAN or 6Low fragmentation. So that's perhaps something else to discuss as well.
Yes, basically we could have text like saying the chic fragmentation was designed to work over a single hop or a single or point-to-point communication. Basically, it's not meant to be forwarded to be relayed. If you want to forward fragments, then all the IRQ system goes away because you don't know how to route the IRQ back, and probably you'd better do something like the Lp1, which the 6LoWPAN fragmentation, which was redesigned for this. And you kind of hint that in your document already, talking about the buffer that we use in the intermediate nodes, etc. So basically, we're talking about RFC 8930 as 8931. So yes, I mean, all this can be discussed. Just a reminder that we put in the architecture things which are kind of agreed inside the working group, things which are stabilizing. Now, the discussion over the mesh, you've just started it. It's very important and very interesting, but we need more interim meetings to agree on what goes, cast in stone in the architecture. And so there's no text because we just started that discussion. I was not ready. I did not have a feel that I could write something that we agreed upon. Because as you know, there is the hard case and the easy case, right? The easy case being when you have repo and non-storing mode tunnel and ingress replication. That's the easy case. And the hard case is going over multiple hop with shake without expanding the packet at every hop. That's hard.
Yeah, that's fair enough. Yeah, thank you.
Okay, do we have any other discussion on either the architecture of rechartering? We are now in the rechartering discussion, and there is no slide beyond the fact that the new things that we could discuss in the architecture, really chic over mesh or even talking about the next header. All this is uncharted for us, so we cannot really go too deep into those things in the architecture. We already have the point-to-point discussion there. So anything else? So if there's none, then we go to the AOB. So do we have any other business? Want to thank Laurent for his hard work on the Young data model. So that's my other business, and also thank for sitting, for Alexander and myself, since we could not be with you, and really we feel bad about this, but that's life. And with this, we'll give you back 4 minutes of your life. So thank you all for attending this meeting, and we'll be restarting interim meetings after the summer break, so somewhere in September, I guess. Thank you all so much. I would like to see discussions on the mailing list on Bob's ideas to fragment with FAQ, etc. That would be nice. Bye-bye. Thank you all.
Hi, thank you.
Yeah.